Hey everybody, welcome to V45, an introduction to energy. This starts our fourth major theme, and energy is one of those areas that you may not think of as a major theme of biology, but as you'll see here in this video series, it is quite important. Here in our initial slide, hey, we've been eating grass. We'll see why that's an important idea here in just a second. And really, what is energy and why is it so important? We'll tackle those ideas in this video. First, let's go back to section 1.1 of your book, Properties of Living Things. One of the properties was energy use. Every organism, every live organism takes in energy, converts it to useful forms, and expels it. So obviously that's one of the fundamental properties of a living thing is that it has ability to take in, use, and expel energy. But now we're left with some questions. What is it? Where does it come from, and why do we need it? So we'll tackle those here. Energy does come in many forms. We can think about the energy required to make our cars go, the energy required here to lift weights, the energy for our light bulbs, and maybe if you're thinking about it closely, the energy we need for our chemical reactions. Here you see ATP and NADPH. These are energy molecules that help make this reaction happen. Now, when I say many forms, you may be thinking about um, electrical or mechanical or potential or kinetic, and we're not going to delve into those areas here. I'd like us to keep the conversation on a little different level. Think about energy, well, why we need it. It drives things, it makes things happen. So energy is going to be important because it really is a catalyst. It makes things happen that would not ordinarily happen, which takes us to then our definition of energy. The traditional definition you see in a lot of places is energy is the capacity or ability to do work. And that is an okay definition. The one I kind of like a little bit better is energy is that which can be applied to move an object that was not going to move and make it move. If you think about, um, in this case, a person standing still, if that person wasn't going to move and you have to move them, you have to apply energy to them, you kind of get an idea that work implies moving something. And that's the definition I want us to think about. When we go back then briefly to we go back to this slide, think about the energy required to make your car move or to make electrons move or to make your muscles move or to make things move inside of a cell. Something is required, something makes molecules move or makes the car move when ordinarily it may not. And that which we associate with almost all of life's chemical reactions and of life's energy sources involves the sun. Your food comes from the sun. Ultimately, the gasoline, the energy to produce those carbon molecules, came from the sun. The sun is the source of our energy. And we need to focus then on some important principles regarding energy. One of them is that unlike nutrients, which cycle, remember the carbon cycle and the nitrogen cycle and the phosphorus cycle, even the water cycle, we don't use up nitrogen, we don't use up water. It's going to cycle, it's going to change forms. Energy, though, doesn't do that. Energy comes from the sun, and the sun is actually much bigger in real life than this. It is. Energy comes as sunlight. Great. Okay, that solar energy is going to be converted to a chemical form by producers, by photosynthesis. Anything that's green that has chlorophyll can process the sun's energy and make it into chemical forms. That's going to then move into animals, into consumers, which is going to be converting the energy from that chemical form into other chemical forms that animals can use. And whenever energy gets transferred around, it's going to radiate back into space as heat. But notice, ultimately, the energy's fate is to leave the system as heat. Heat is a good thing, I suppose, but heat doesn't make our chemical reactions happen. So once the energy goes back out into space, we better have another source. We better have more energy coming in And that again is the purpose of the sun. The sun's energy is going to be moving through the system and ultimately out. Again, the cycling we saw with carbon and nitrogen and phosphorus was truly a cycle, that we're going to see a pathway, a cycle, a recycling, if you will, of the nutrients. But we don't see that with energy. Energy flows through, flows through. That is going to be lost ultimately as heat. Now, that idea that energy flows through ecosystems is extremely important to understand. How does energy start in living things? Primary producers, okay, think about again green things, think about the plants. They're going to convert the solar energy into chemical energy through photosynthesis. You can't do this. You can't lay outside and convert the sun's energy into energy your cells can use. You lack chlorophyll. You can't carry out photosynthesis. But understand again, that's how it all starts. The energy that you need, the energy you use, ultimately comes from the sun. But since you can't directly convert the energy, we have to depend on primary producers to start the process. Now, primary consumers are those things that eat the producers. So in this case, we have some caterpillars. Okay, caterpillars can't produce their own food, but they can convert the energy that we have in plants to make caterpillar energy, caterpillar parts. Secondary consumers are going to eat the primary consumers. So the consumer here, that term consumer, means that you cannot produce your own food. You must consume something else. You must consume the plant, or you must consume the thing that consumed the plant for you to get access to that energy. We can go further. We can think about tertiary consumers are the next level up. And these are top level predators. And we'll get to this idea about energy transfer here in a second, so don't sweat this. And finally, though, decomposers are going to break down everything that was alive, that died, so that we can recycle some of the nutrients. And it also allows us to process things so we have more material available for future photosynthesis. That is, you break down the plants, the plant parts get recycled, we can make more plant. However, please understand, the decomposers don't recycle the energy. The energy is going to ultimately be lost as heat. So we're now getting to that idea of relationships between the different critters here. So let's start here. We see the same pictures we had before. I'll try to grab my pencil. Okay, so here is the first trophic level. Whenever you see this term trophic, that means feeding level. So the first level, troph means to eat. So the first level are the producers. And again, see how the sun, the energy is going to be captured, some of the energy will be captured by the producers. The caterpillars, in this case, the primary consumers, eat some of this, some of the plants. They're on the second feeding level. The third feeding level is when the bird eats the caterpillars. The fourth feeding level is when the fox eats the birds. So again, these are all of the trophic or feeding levels that started ultimately from the sun. Now, this line represents what's called the chemical energy. Some of the plants and caterpillars and birds and foxes, are going to be processed by the decomposers, but ultimately we end up with this statement down here. It's a little hard to see. Let's see if I can make it visible for you. At each energy conversion, heat is released. You see up here, every case, some energy is going to be lost as heat. So if let me move out of the way for a second. In fact, let me go away here just a moment. Notice how at every stage, some energy is lost as heat. There's a reason for this. Energy transfers are not very efficient. From one trophic level to the next, only about 10% of the energy transfers. Only 10% of the energy transfers. If you start with 100 units of energy down here at the bottom, Let me grab a pencil. Um, if you start with 100 units of energy, when the primary consumer eats the producer, only 10% of that energy gets transferred to that consumer. A lot of the energy is going to be released as heat. When the secondary consumer eats the primary consumer, only 10% of the original 10% gets transferred. As we go up to the third level and the fourth level, just listen carefully. I'm going to go 10% of the 10% of the 10% of the 10%. So only a very small fraction of energy from the original producers gets to that fourth level of the, in this case, of the food chain. That's really important because it means that you can't have lots of these, in this case, lots of fourth level consumers, because there's not a lot of energy that reaches them. Every time we have a transfer, we're losing some energy as heat. So there's just not very much energy left by the time we get to this top level. So this might be able to see it easier in what they're calling a food pyramid. So here we have 2 million calories of sunlight that enters the ecosystem. Okay, that's going to enable us to make this much corn, which is going to allow us to support this many people, 10 vegetarians, because we're going to have, once again, 10%, that's going to be what? 200,000 calories, which will allow us to get 2,000 calories for them. However, if we were to pass that energy through one more layer of the food chain, we're going to have less energy available. So if we go 10% to 10% to 10%, if we pass it through one more level of the food chain, that is, if we eat an animal as opposed to the plant, we can support only one person as opposed to 10 people over here. There is an expression that was popular in the 70s called eat low on the food chain, which basically meant if we can eat more vegetarian foods, eat more other producers, and not pass it through this level of the food chain, more energy would be available to us and we could support more people on it. This has implications for population growth. Can we support long-term the American lifestyle, which is to eat lots of meat? This would suggest that it could be more efficient if we ate less meat because we could support more people. And again, if you don't understand why, go back to the previous slide. 10% of 10% of 10%. We call this, oddly enough, the 10% rule. So just showing you, to wrap up here, a couple of relationships. This is demonstrating the food chain from a plant to a herbivore to a carnivore. These are some new words. Herbivore just means to eat plants. Carnivore means to eat animals. So here you see a food chain, which is showing you one path of energy, a simplistic look at transfer. This is much more realistic over here, a food web, because in reality, this squirrel is going to eat, was that squirrel or chipmunk maybe? This is one that's going to eat multiple things, and multiple things are going to eat it. This grasshopper is going to eat, in this case, just the grass, but several different things may eat it. Every time you see a line drawn here, that's showing you how energy is being transferred. So a food web is a much more realistic way of looking at food transfer, but it's also more complicated. This is an easier way of looking at trophic levels. This is a far more realistic, but far more complicated way of looking at those same transfers. Just to emphasize one more time how energy transfers affect numbers. Okay, what do I mean by that? Think about down here the producers. How many plants are there in the world? A lot. Okay, how many primary consumers are there? I can argue there are fewer primary consumers than plants. There are fewer secondary consumers than primary consumers. How do I know this? If the 10% rule is true, and it appears to be, how many we'll do this. How many grasshoppers must the frog eat? Not just one, it must eat, let's say, 10 times. It must, to get enough energy going to that frog over and over and over again because of energy transfers are not perfect, it's going to have to eat a lot. There's not enough grasshoppers to support the same number of frogs. There has to be fewer secondary consumers than primary consumers. There has to be fewer tertiary consumers than secondary consumers. Or think of it like this. How many of these are there in the world compared to these? A lot fewer. And why? Because energy transfers are not 100% perfect. And because of that, the top animals have to eat lots of lower animals, which eat lots of lower animals, which eat lots of lower animals, which eat a lot of plants. Again, the source of the energy, do I have a yellow? Yes. The source of the energy for the whole thing, of course, is going to be the sun. So that's why when we look at an ecosystem or an ecological pyramid, there's a lot fewer of these than there are of those. And the reason is because of energy transfers. So that's our basic introduction to energy. An assignment is next. Thank you.